This is Euclid Book 7, proposition number 5. You can go ahead and draw this out because you're going to need it. Go ahead, pause the video, draw this out. Okay, this one is real easy. If a number be a part of a number and another be a same part of another, the sum will also be the same part of the sum that the one is of the one. Now you're probably sitting there going, what? What did he say? Okay. For let the number A be part of BC. Well, we're going to say that A is 2. And we're going to say that BC is 4. Well, 2 is a part of 4. And another D, the same part of another EF as A is of BC. Okay? Well, what we're going to do is we're going to say that D is 8 and that EF is 16. And 8 is half of 16, just like 2 is half of 4. Okay. I say the sum of A and D, if you add A and D, which is 2 and 8, that's going to be 10. It's also the same part of the sum of BC and EF. Well, what is the sum of BC and EF? Well, the sum of BC, 4 plus 16, okay, 4 being BC and 16 being EF. If we add the 4 and the 16, we get 20. And 10, as we're going to prove here, 10 is half of 20. We're going to prove that. For since whatever part of A is of BC, D is also the same part of EF, which we established. Therefore, as many numbers as there are in BC equal to A, so many numbers are there also in EF equal to D. Well, there are 2 2's in BC, and this is also true of here because there are 2 8's in 16. Okay. Let BC be divided into the numbers equal to A, mainly BG and GC. Which of course we did. And EF into the numbers equal to D, namely EH and HF. Well, here's EH, here's HF, and the length of EH is 8, EH is 8, HF is 8. Same thing over here. BG is 2, GC is 2. That's what they're saying. Let's go on here. Then the multitude of BG and GC will be equal to the multitude of EH and HF. Well, the multitude of BG and GC is 2, and the multiple of EH and HF is, of course, 2, which we have said. And since BG is equal to A, and EH is equal to D, therefore BG, EH are equal to A and D. For the same reason, GC and HF are also equal to A and D. Okay? And we've already established BG is the same size as A, EH is the same size as D, GC is the same size as A, and HF is the same size as D. We've established this. Therefore, as many numbers as there are in BC equal to A, so many are there also in BCEF equal to A and D. Therefore, whatever multiple of BC is to A, and the same multiple also is the sum of BC and EF to the sum of A and D. Therefore, whatever part of A is of BC, the same part is also the sum of A, and it goes on and on. Okay. So we've already established that there are two A's in BC. And if we were to add BC and EF together, then there would be the same number of A and D's in that. Okay? And and he just kind of goes around Mulberry's bush, basically. But that is the proof right there. Okay? Because the last statement says, therefore, whatever part A is of BC, the same part also is the sum of A and D to the sum of BC and EF. So what they're doing is they're adding 4 and 8 together. That's A and D. And they're adding BC and EF together. Well, BC is 4 and EF is 16. Well, 16 plus 4 is 20. And 2 plus 8 is 10. So 10 is half of 20. And that's the proof. So he goes completely around Mulberry's bush to make this proof. I know, you're sitting there going, why did he go to all that trouble? We could have figured this out in about 10 seconds. But that's what he did, and now you know. But you could do this with thirds, you could do this with half, you could do this with fifths. Doesn't matter. The point is, the proof works. Alright, I will tell you more in a future video. Stay tuned.